Of how to do the type 1 binary nomenclature practice number 1 sheet. So again, it's type 1 binary. Now type 1 means that it's ionic, and it's monoionic, I should say. So it's the ones that only have one charge. So these are elements that are going to be ionic compounds that have only one charge. So that means that if they're a metal, they're going to be in type or in column 1, 2, or 3, or one of our 3 exceptions, okay, that we can look on page 12. They're also going to be above the staircase for the negative ions. So the cations are metals below the staircase, nonmetals are anions above the staircase. So let's go ahead and look at the first question here. It says, list the oxidation numbers or the charges for each of the following elements. So we're going to basically give down here what the charge is. Now, how do we figure out what the charge of Ca is? Well, first of all, if you don't know what Ca is, it is calcium. But we can go ahead and look at our periodic table. And let's just go back up to our periodic table. So here's our periodic table. We found that Ca is right here. It is calcium. It is in column 2 of the periodic table. So that means it's 2A. And that means it has a +2 charge. Okay, we can also look in your packet by scrolling back all the way down to page 12, and we can see that here it is, column 2A, Ca is a +2, or 2 plus. So let's go back to the question. So this one right here would be a +2, or if you want to write it 2 plus, that's fine. We go on to the next one. We have nitrogen. Nitrogen is N, okay? So we look at our packet. We can go over here. We can see nitrogen is a -3, or 3N. Or again, if I go up to our periodic table, we can see that we have 1A, 2A, 3A, 4A, 5A. Now remember, it needs to get to neon, the noble gas electron configuration. So it needs to add 3 electrons, 1, 2, 3. So this would be a -3 charge. So go back to our thing here, and we're going to put -3. Okay. We can also look at these groups. Remember, this is group 15 or 5A, 16 or 6A, 17 or 7A, and then we can go to zinc. Well, zinc is one of those ones. If I go ahead and look at my packet, I see zinc right here. Well, there's no charge. This is in the B group. So is it one that has only one charge, or is it ones that have multiple charges? Well, the best way to do that with zinc is to go ahead and pull all the way back down to page 12. Here's page 12. Well, there's zinc, so zinc is going to be a +2. Now, another way to look at this too is that here are the 3 exceptions, okay, that are not in column 1, 2, or 3A. But they're in the B group that we call these ones that are down here. Remember, this would be 3B, 4B, 5B, 6B, 7B, 8B, 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 1B, 2B. So these ones right here that are in that, if they're in 1B, it's +1, 2B, +2. Okay, let's go back there, and that's what we put in there as in a +2. So let's go ahead and go down to write the formulas for the binary compounds. So these following binary compounds, the first thing that we're going to do is when we write the formula is we're going to do the charges. So we're going to look at calcium. Well, I have calcium right up here. Calcium's a +2. Well, let's go to oxygen now. What's the charge for oxygen? Well, let's go to the periodic table. Oxygen's right here. This is a handy one for type 1. Okay, oxygen is a -2. So go back to my paper. Oxygen is a -2. They do cancel each other out. And a lot of times you'd say, well, we're going to crisscross. Well, we crisscross, but we can reduce. So since they already cancel each other out, that means we only need one of each one. So I can put Ca, and then I can put O. There's the formula for calcium oxide. Okay, let's do the one right below it. We have potassium. So I'm going to potassium oxide. So I'm going to find where potassium is. Okay, go back to here. Potassium is right here. It's a +1. Now again, I can go ahead to my periodic table and do the same thing. Here's potassium. It's in column 1A, so it's a +1. Go back here. We're going to put a +1 right there. Go over to oxygen. Oxygen, we just did it up here. That's a -2. They do not cancel. Because they don't cancel, what do? We crisscross. So I put the 2 down here, and I put the 1 over here. So that means I'm going to have K, the subscript of 2, and then O. So remember, the 2 comes over here, the 1 goes over on the other side. We don't put the 1 as a subscript because it's not necessary. I can't put a 0 there. That would mean I have 0 oxygens, but we do have 1, so we don't put the 1 down. Okay, let's go down here, these other ones. These ones right here, these are a little bit easier. We have KO. Well, we just did that when we know it's potassium oxide. But when we write the binary name, all we do is say the metal, and then whatever the non-metal is, we change the ending to "ide." Okay, so we're going to rearrange it to be "ide." So let's just go ahead and do this one right here. We have CS and I. So that we know that CS, we got to find CS. CS is right here, so it's going to be cesium. And then we have I is iodine. So we're going to call this one cesium iodide. Okay, and I spelled that wrong. So iodide. So remember, we take the non-metal and we change the ending to "ide." So in all of these, the second element should be a non-metal. The first, if it's ionic, so type 1 or type 2, we know that the first metal one's a metal and the second one's a non-metal in the binary ones. Okay, let's do it one more before we go. Okay, so let's do this one right here. I have Rb and Cl. So I go to my periodic table. I find Rb is rubidium, and go over here to Cl above the staircase. Cl is chlorine. So we're going to call this one rubidium chloride. Okay, so there's how we do it. So we had to name and we had to write the formula of these compounds, these binary ionic compounds, which we basically know as type 1. Okay. Hey, hopefully it helps you out. You can do the rest on your own. If you have any questions, remember you can always ask in class. Hey, as always, Nelson out.